All right, let's take a look at this idea of information infrastructure and its architecture. Now, when we look at the term infrastructure, it's really the base or the foundation within which the information systems are going to be deployed. Now, that means it's going to be comprised of computing platforms, of networks, middleware layers for a wide variety of applications. But the infrastructure is just that. It's the way I look at it is how everything is interconnected and capable of communicating with each other. So when I think of an infrastructure for information systems, I'm thinking that there are, of course, cables, there's ports, there's switches and routers, there's the servers, the software running on the servers or the operating systems, and all of these things that are involved to be able to really support our goal. So that's the architecture. One of the things you can say, though, in today's world is that there's a lot of complexity within the infrastructure. As the business environments grow, many of your business processes and support functions are going to have to integrate quite seamlessly to be effective. That can be seen as, again, increasing complexity. Now, I've utilized this analogy several times, but it still holds true. If I think about ordering something online and I connect to the web, well, if I don't want to count, the home user's PC and the internet service providers they have to go through to get to my service provider, to get to my server. If I don't want to include that into my complexity, I guess I can leave it out. But there's a piece of it that we still have to look at. But then, for me to make the order, what has to happen? Well, your web server is going to have to probably connect to some back-end database server. That database server will provide information that it can use to show what's in stock or in inventory and what the prices might be. That back-end database server probably also keeps track of my usernames and passwords, or it has to integrate with some other type of authentication server to verify who I am when I log in to make and place my order. I also know that I want my order to be done through encryption, so now I have to have encryption technologies, SSL or TLS, which usually means that there has to be a certificate authority that has issued certificates at least to the server. Now that I've gotten to that point, if it's still not complex enough, I'm going to put in the information and give you my credit card. From there, that application has to go out to a banking complex to look at that card to see if I have funds available. And then from that to be able to transfer it to its banking account. So now it's making multiple bank connections, which may be going through several credit card processing centers. Then, of course, we have to notify the inventory department to make sure that it's actually in stock, have it sent out to shipping, where shipping can then worry about getting it packed up and put onto a shipping server to be able to get that product to my home. All right, so in one little easy transaction, I hope that I've described the complexity that we might be talking about. And that was just for ordering something off of your web server, not counting all the other type of complexities that are a part of your infrastructure. So that means we have to really provide a framework and a roadmap to be able to make some headway into working or managing with complexity. We often think of the architecture as a way of working for us as that roadmap. Now, there are some things we can do to try to break this down. We can add simplicity and clarity by layering or adding modularization. The example might be is if I'm going to build a brand new housing subdivision, what do I need to put in? Well, I'm thinking that before I have to put in any of the homes, I'm going to have to probably put in the sewer system that connects to the city and the water system to connect to the city water or however the case may be. I'll probably have to make sure that our underground lines are there for telephone, TV, for power to the homes. And once I get that built in, then I can worry about laying out the roadworks, the roads, and starting the paving on the roads. Having people break down again the different lot sizes, and then going in from that point forward. So what I'm saying is that a subdivision has some very much complexity to it, but if I approach it in its simplicity and clarity, and looking at it layer by layer, it's pretty easy to see it in its totality, because I realize that through good planning, through layering, through modularization, I can deal with the issues of saying, okay, gas lines, water lines, sewer lines, power lines, cable TV, get that done. There's my foundation. Build on top of from there, and it goes hopefully much smoother. Well, we can do the same exact type of clarity and layering in our infrastructure design. And now from there, of course, the other thing that we see in the complexity is, the business focus. And when I say that is, I've really kind of relied on the technical domain in my description. I mean, sure, we talked about housing tracts, but I'm talking about the infrastructure, the network infrastructure, and really to even make it more complex, we have to realize that our business focus does go beyond the technical domain of what it is that we're trying to accomplish. And really, our technical domain is designed to help support the business focus. Now, having said all of that about complexity, we have to realize that architecture and control objectives are considered in combination of technologies to be able to provide what we call control points within a system's infrastructure. Now remember, this idea of architecture is something that's around 10 years old, and that can act as a framework or help us in providing the roadmap to being able to get to certain goals, especially as we're talking about security programs. So in that part of it then, when we look at the architecture and we know what our objectives are with the controls, that we know that, as I said, that those things are going to be combinations of technologies. It could be combinations of policies and procedures, but we use them as control points within our system. Now, some examples of the architecture policy domains that you might deal with, things like your database management systems, your telecommunications, your web applications assets, or being able to access them as well. Again, those are all things we have to look at as far as managing complexity. With the web application, I already talked about, as an example of having an architecture or control objective to provide encrypted communications and what we'd have to do to work within that domain of web applications. In telecommunications, if it's voice over IP, we may have discussions about segmenting the traffic so it can't be easily intercepted by the people on the data portion of our network. And database management systems have their own authentication systems, their own authorization systems, their own way of breaking down the databases into manageable pieces, and as well as adding control points for security and authorization. All right, well, let's take a look at what the objectives are for the information security architecture. Remember, the underlying idea for the architecture is that the objectives of a complex system has to be something that we can comprehensively define, that we can have precise specifications, and that their structures are going to be engineered and tested to perform and fit and function. Now, we also know that we have to have the performance monitored or measured according to the design objectives. So then what we're seeing here, then the objectives of that architecture for information security is trying to help us in solving the complexity issue. But it won't do that, as I said, unless there is a good definition or a comprehensive definition and precise specifications. It just can't be a bunch of wandering, ambiguous types of terms. It has to mean something and be something I can look at and say, okay, I got it, I see the structures, I can test them, I know what the goals are, I know what the specifications are. Now, unfortunately, little exists for an overall comprehensive enterprise security infrastructure or its management as it relates to the business objectives. So this is an area that's still growing and, of course, is going to add some work for us in the security management field to be able to relate to complex systems. But it is a beginning to have examples of architectures that we can look at to help us in trying to come up with this kind of a design. Now, one of the things we can look at is like the SABSA model, the SABSA. It has 6 different layers that can help us in assisting in developing a model for an enterprise architecture. In looking at it inside of these different layers, we can look at it and it defines some of the layers as the business view. In the business view, that's kind of the contextual security architecture that we're going to use. The architect's view would be the conceptual security architecture. Now, all right, so we so far we're kind of getting that, right? The business view, we know in context what we needed to do. The architect says, okay, I can see that vision, And then the designer says, okay, I will do the logical security part of it that meets that conception that you have, the conceptual view, to meet the business's contextual view. Now, from there, the designer is working on those logical security architectures, but the builder will also be looking at it from the physical security architecture. The tradesman's view is that they're going to deal with the component security architecture, whatever that component might be. It could be PC, peripherals, it could be parts of the infrastructure. And of course, the facilities manager's view is to look at the overall operational architecture. Now, as we look at a little more precisely to things like your physical and environmental controls, we need to remember that no matter how good your technical security is, it can be easily thwarted by having a lack of good physical security. In fact, that's been the subject of many good movies where, this mainframe of data we want is not connected to the world, and what was it? We had to send somebody through a little hole in the roof on a rope, and they couldn't drop any sweat. They had to, all these little cool things. It was like, wow, I really like that idea of showing you that as much of that security as they have, that it was still, lacking in physical security. All right, well, it didn't appear to me that it was lacking in that movie, but they found the vulnerabilities, at least, we could say. Well, I look at the philosophy of if I can touch it, I own it. And that's true. For any physical mechanism, I can look up how to override the logical controls. And that's, like I said, every vendor I've seen has on its website how to do a password recovery. And if I can do a password recovery, most often the existing configurations are not erased. I know they were on a couple firewall products that I worked with, which I thought was kind of cool. But even then, erase is not zeroing it out. We talk about that, about data disposal or destruction, which means I could have still forensically recovered it off of their solid-state drives. Anyway, again, I'm starting to ramble a little bit there, but I'm trying to say physical mechanisms are easy enough for me to break in and own that technology. So that means we have to use physical controls to help mitigate the damage, especially looking at the physical controls for the facilities and using other resources that might maybe be of a natural or technological event. And again, right, physical controls can help us for some things. The design of the buildings, of course, for a natural event might be designed to help protect against hurricanes or tornadoes. It's just a matter of how you set it up. As a quick example of a physical control, the actual design of a building that I was in, working for a company in Florida. It was a beautiful view, and I was about 30 floors up, a beautiful view of the ocean. And I asked them, I said, tell me about this building if there's a hurricane. And I only asked because there was one coming. It missed us. But anyway, they said, well, you're probably safer in this facility. They told me how the glass had been designed for winds up to 175 miles an hour and designed for shatter capability in case the wind was throwing objects at the building. And that how the power grid was backed up by a generator that they had deep under the ground with, I don't remember how many tens of thousands of gallons of propane to keep that thing running. And they had a full kitchen, and it was like a little fortress, but it was a beautiful building. And I thought, well, that's pretty cool. As a physical control, trying to protect the information, the kind of things that they were needing to keep safe were pretty intense. But it was a great facility. And I thought, all right, there's some examples again of types of physical and environmental controls. Of course, I like giving you the extreme sides. Not every one of us can have that kind of a building, but that is the goal. Now, from there, I can tell you the physical security was also quite good as far as what it took for me to get in there and the fact that I had to be escorted most places.